Okay, so having described structures, functors, and signatures, I want to conclude this lecture with some general remarks. Okay, so firstly, notice that we really need only values, types, and functions. Okay? But what structures and functors give you is for programs. Okay? Structures structures gives modularity and abstraction for repetitive for coding in large. Okay, in what sense? For example, we use or overloading. Okay, so you can define a structure. You can define a functor which contains, for example, algorithms to sort. For example, something like this. So, for example, you can define, let's say, functor sort, which takes a structure O of type ort that we saw already, okay, and gives a function val sort O dot t to list to O dot t list. Okay, so let me capture this as a sort. Sort x is equal to blah, 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 but I am just for time being defining it as the identifier. Yeah. So this sorting function I can write, and I can instantiate with different ordering structure. Okay, so this is how you can make use of structure to build modularity into coding in large. Okay, and the second point is that the second point is it helps. It is it can be used for some type safety issues. It can be used to implement abstract types. Okay, we will see this in some detail. Essentially, the idea is types which can only be processed in a specific. We will see this in some detail in coming lectures. So main idea here is this is mostly for programming in large. Okay, and functors gives us this immense power which hardly any other language supports. Okay. Okay, and an important point here is that it is in some sense at the meta level, by which I mean this is not at the value level where the real programming happens. It's at a level higher. Okay, if you think of the values and functions and things as workers, so if you think of values, functions and types as your workers, then the structure functor is the managers of things. Okay, although a more friendly manager, I guess. Okay, so that's the main important thing that I want to say. Having said this, there is an important analogy which I want to discuss. Okay, this is an important analogy that is good. The structure layer is similar to the values layer. Okay. In what sense is that? Let me explain it with a table. Okay, so we have values here, and the corresponding object there are structures. So it is given by the val keyboard, right? Defined using val keyword. Okay, and here structure and struct. Okay. Then you have types which are specs on value. So it kind of says what the value is for. And here we have signatures, which are kind of specs on structures. Okay, in the sense that it controls or it says what the structure expose and things like that. Finally, you have functors, and that are the functions. Maps values to values, and what you have here is functors. Map structures. Okay. This layer is similar and quite analogous. In fact, there is some kind of similar structure for all these things. Okay, and finally, the fourth important, or maybe one of the other important point is that structures give a zero cost abstraction. Okay. So what do I mean by that? ML with structures is as ML without. Okay, so if you look at a variant of ML which has structures and which doesn't have structures, the final executable a compiler can generate is of similar complexity. In fact, the Hamilton compiler first defunctorizes. Okay. So when I talk about efficiency here, I mean efficiency of the executable that is generated, not the efficiency of compilation. Of course, there is a pass of Hamilton which removes the structures and functors. Okay. Removes structure and functors. Okay, and this is a zero cost. Okay, and the fifth point that I want to say is that structures, SML like structures can be added to any language. Okay, so this is, although we have studied it in the context of structure of a standard ML, similar modularity. Okay, so here the most important feature here is the functors. Okay, because they allow a kind of flexibility that hardly any other language supports. Okay, so structures and signatures probably are available in most languages in terms of modules and controlling the behavior, but functors is something unique to the standard ML and OCaml and similar cassettes. But that doesn't mean that you can I mean, this is some cocked up thing. In fact, for any language you can add something like a SML structures. For example, you can have C with SML like structures. Okay. So these are the points that I wanted to discuss. Okay, we will look at some applications of these structures and functors in the coming lectures.